Hello and welcome to the second video of the 4-video series on understanding significant figures. This video focuses on math rules specifically. After watching the first video and learning the basics, you should have a good understanding of what significant figures are, when and why you need to use them, and you should also be able to identify how many significant figures are in different decimal related numbers. The goal of this video is to instruct you on the fundamentals of adding, subtracting, multiplying, and dividing numbers while paying attention to significant figures. Just as there are rules for determining the number of significant figures in directly measured quantities, there are also rules for determining the number of significant figures in quantities calculated from these measured quantities. In this video, we will be focusing on those sig fig calculations. When you add or subtract numbers, the actual number of significant digits do not matter as much as the actual precision of the numbers or measurements you are adding or subtracting. The result can only be as precise as the least precise number. When doing this, I find it easiest to stack the numbers vertically, whether I am adding or subtracting. This will help you keep track of how many decimal places you should include in your result. The first step you should take in solving both types of calculations should be doing all the math and writing out the full result you see on your calculator. Then you can start to determine how precise your result should be. Here is our first example problem for addition. We have 14.0168 added to 1.2. And I calculated that is 15.2168. As you can see here, 14 has 4 numbers after the decimal place, and 1.2 only has 1 number after the decimal place. That means that our answer will have only 1 number after the decimal place. I find it easiest to draw a line here after the last decimal point that shows me where our answer will need to be cut off. After that, we will have to determine if we need to round up or round down our answer. In this case, there is a 1 after the 2, so our final answer will be 15.2. For my second example, I have 3 numbers that are being added up, and I have them all stacked vertically so we can see what our result should look like. We have 89.00 plus 15 plus 112.2591. And the result I got from that was 216.2591. As we can see in this first number, there are 2 places after the decimal. After the 15, we do not have any decimal places, so that means that our answer is going to be a whole number. As I did in the last example, we're going to draw a line here straight through our result to show us what our result will be. Since 15 has the least amount of decimal places, it actually doesn't have any decimal places, our result is going to be a whole number. We can check and see the decimal place after the 6 is a 2, so that means our answer is going to be 216. Here is a subtraction problem. We can look at this the same way we approached the past 2 addition examples. So here I've lined up the numbers vertically. I've calculated our result as the first step. So here we have 77.691 minus 26.2282, and that gives us a result of 51.4628. In the first number, we have 3 numbers after the decimal point. In the second number, we have 4 numbers after the decimal point. Picking the least precise of the 2 is 691 with 3 numbers after the decimal point. So we will draw a line here indicating where we need to cut off our result. After drawing the line, we can see that our result will only include 3 numbers after the decimal place. So our last step is looking at that last decimal place 2 looking over to that 8, and we see that we're going to need to round that up to 51.463, and that will be our final answer for this problem. The rules for multiplication and division differ slightly when compared to addition and subtraction. The rules are practically opposite. Now we are paying attention to how many significant figures are in each number we are multiplying or dividing, and we will state our result with the least amount of significant figures in the multiplied or divided numbers. This may be hard to understand when I say it, but pay attention to the practice problems I'm about to go over, and it will make sense to you very quickly. Just like I told you for addition and subtraction, you should always start by writing out the full result of your calculation before you start to figure out how many significant figures need to be included in your result. So here is our first example for multiplication. We have 409 times 37,000, and that gives us an answer of 15,133,000. In 409, we have three significant figures. We can include the 0 because it is sandwiched between two numbers. However, in 37,000, we only have two significant digits. We are not including the 3 zeros behind the 3 and the 7, the two significant digits, because there is no decimal point after the 3 zeros. So now we've determined that our answer can only include two significant digits. For this problem, our answer will be 15 million. Here is our second example for multiplication. We have 0.0006 times 761, and that gives us 0.4566. In our first number, we only have one significant digit. We can ignore all the zeros to the left of a significant digit. In our second number, you can see we have three significant digits. So our answer can only have one significant digit found in the first number. So looking at our result, we have 0.4566. Our answer is only going to be including one significant figure, so we will have one number after the decimal point. Looking over to the next number 5, we can see that we do need to round up, so our final answer is going to be 0.5. Here's a division problem. We can look at this the same way we just approached the last two multiplication problems. We have 3 divided by 16, which will give us 0.1875. Now let's take a look at how many significant figures we have in each of the two numbers we're dividing. In 3.000, we have 4 significant digits. We can include the last 3 zeros because they were after a decimal point. 16 has 2 significant digits. Now we know that our answer can only include 2 significant digits. Our last step in solving this problem is figuring out if we have to round 0.18 to 0.19, and we do because we have a 7 after the 8. So our answer for this problem will be 0.19. Here is our last example problem. We have 2,756 divided by 16. That will give us an answer of 172.25. 2,756 has 4 significant digits. 16 has 2 significant digits. So now we know that our result will include 2 significant digits, the 1 and the 7. We take a look over to the next number, we see it's a 2. So we know that our final answer will not have to be rounded up, and it will be 170. After watching this video, I hope you have a greater understanding of how to both add, subtract, multiply, and divide measurements while paying close attention to your significant figures.